So warm up number 57 is on your screen, and it reads, number one, write in slope intercept form and graph 6x minus 2y equals 10. Number two, graph f of x equals x cubed, then transform using g of x equals f of parentheses x plus 8 close parentheses 5. Number three, it reads factor. Part A is x cubed plus 3x squared plus 3x plus 9. And B is x squared plus 8x plus 12. Number four, divide the polynomials with synthetic division. Polynomials given, x squared plus 5x plus 6 divided by x plus 2. And last but not least, number five, solve the system by using substitution. And they give us a set of x plus y equals 3 and x equals 5 minus y. All right, copy that and see if you can finish that a little bit faster now that we've been seeing these already for a couple of weeks. Okay, give you some time. Ready and go. So, number one, slope intercept form, you should have gotten y equals 3x minus 5. Let me graph that over here. Let me make some space. Oh. There it is. Oh. More. There it is. So let me get my coordinate plane going. That kind of crooked? It's kind of crooked, right? There it is. All right, so to graph this, once again, we start with a y-intercept, which is -5 on the y. -5 is down here. And the slope is 3 over 1. That means 3 steps up, 1 to the right, 3 steps up, 1 to the right. And your graph, it's a straight line going through those points. Pretty good, yeah? All right, number two. For number two, it says graph f of x equals x cubed. This is a parent function, and we know that we always start at 0, 0, as we mentioned before. Let me see. Yeah, actually, all the functions that we're going to cover this year, they're all going through the point of origin. So starting at the point of origin, 0, 0, what do we do next? We take -1 cubed. -1 cubed is -1. And -2 cubed is -8. Somewhere down here. 1 cubed is 1. 2 cubed is 8. So our cubic function is as follows. There it is. But then they want us to do a transformation, which is g of x equals f of x minus 8. And I'll put the little cube there, minus 5. So what does that tell us to do? Look at it. What are they telling us to do with this transformation, Jesus? Jesus, are you there? Do you have?
Yes, I was thinking. I was in the one of the last one. My bad. What was it?
What is this asking us to do?
8 to the left and 5 down.
8 to the left, 5 down. That is correct. Or my vertex would be -8, -5. So if I go to -8, -5, -8 is over here. -5 is this one. So then my new, instead of being 0, 0, we move it over here. So the entire cubic function moves to the left and down. There it is. Number three, factor. Is it in standard form? Yes. Can I get any GCF out of the way? No. Let's group the first two, the second two. GCF for the first two is x squared. We're left with x plus 3. Plus GCF for the second two are 3. We're left with x plus 3. So what's the same there and there? Well, x plus 3. And what's left over? X squared plus 3. 3b. Factor is in standard form, yes. GCF, no. Power Rangers, 12, 8. Factors of 12 that add up to 8, 6 and 2. Since this one does not have a leading coefficient, then we can just write x plus 8, x plus 2. Number 4, divisor, we start with -2. And we divide using quotients, 1, 5, and the constant. So that means I bring this down, times that's -2, that's 3, times -6, 0 remainder. So my quotient is x plus 3. That's my quotient. And if we multiply that times a divisor, we should get the original dividend. And last but not least, number 5. What'd you get for number 5? Let's see. How about Ivan, what'd you get for number 5?
I don't know.
What's that? I couldn't hear. Help him out, Angie. What'd you get for number 5? Angie, you there?
I haven't done that one.
You didn't do it. Come on, Angie. So first things first, we need to set it equal to, solve one of the equations. This one's already solved for x. What is x? 5 minus y. So on the other equation, I'm going to replace this x with that. So I write 5 minus y. I bring down the plus y equals 3. And I start solving, combine like terms. Negative y plus y, they cancel. We're left with 5 equals 3. Wait a minute, no variable left, just 5 equals 3. Is 5 equal to 3? No. So what does that mean?
No solution.
No solution, that is correct. No solution. In other words, no intercepts. So those two linear equations are not going to intersect. So let me extend another question. This is going for Addie. Ready, Addie? Here goes a question, so you can think about it. If these two equations are linear equations, which means they make straight lines, and there is no solution, which means no intersect, what kind of equations are those, or what kind of lines are they?
Separate?
They are separate, that is correct, but if they never intersect, let's see, help them out. Hayden, what do you think?
Parallel.
Parallel. Bam. Yes. All right. So that was a warm up. Let's go to the agenda for today. We have warm up number 57. We already finished. Today we're revisiting dividing polynomials with synthetic division. The reason being, even though I've been giving you plenty of practice, I just have a slight suspicion that some of you might be doing other things during the warm up. Some people, Ivan, some people might be doing other things. And your home plate for tonight is going to be 8 extra problems for practice. Now, today we're going to go over some examples. So it's going to go pretty quick. I wasn't going to make a video for this, but I am, just so that it can be there as support for those of you that need to see the extra practice once again. But like I said, a video for this should be already in my YouTube channel. So make sure you go to my YouTube channel, look for it, Synthetic Division, or go to Google and Google Mr. Q's synthetic division. All right, so our asynchronous session code is P46IQ. P46IQ, make sure you copy that. You're gonna need that for the 8 problems for the home play for tonight. P46IQ. All right, and your previous home play was to do a take at home pop party. So go to Canvas right now, turn that in, please. It's only 6 problems. It was only 6 problems. So make sure you turn that in. I'll give you guys some time for that. So, should have already submitted your pop party. Now, for those of you that are barely taking pictures, I had said last time we met, after you finish the pop party, take pictures so you're ready just to submit when I ask you to submit. My goodness. Okay, just wanted to emphasize on that. All right, your home play for tonight, 8 problems are on the screen. It says divide, and like I said, today's gonna be practice of dividing using the synthetic division. I'm gonna leave them, they're in the asynchronous session, so make sure you copy the asynchronous code so you can go in there and get those because they're kind of hard to copy from the screen. So let's move on, okay? So today's objective, I can divide polynomials with synthetic division. Once again, I can divide polynomials with synthetic division. This is a revisit to this lesson we already saw in semester 1, but I'm emphasizing, pay attention to what I'm saying, what we're gonna do next week with the functions that are coming up in regards to polynomial functions. You need to have synthetic division down like cold, like out cold. You need to know this. You need to wake up every day and be like, oh, synthetic division. You know, it's one of those that you need to know it, and it needs to be like ingrained already in there, because in the problems that we're going to get next week, in order to graph, in order to factor, in order to do what we're going to do, you need to do synthetic division with one problem several times. Let me repeat that again. Several times within one problem. So that means you need to know this process. Okay? Yes, Mr. Q. So our concept for today, once again, polynomials. What are polynomials? For the sake of time, definition, monomials or sum or difference of monomials. Now, those of you that were with me in 8th grade, you should have that like out cold in your noodle by now, yes? And like I told you, you're not gonna be, you're gonna be seeing polynomials all through your educational career from this point forward. Examples: 2x squared negative 3x to the 4th plus 2, x squared minus 3x plus 2. Non-examples: 2 equals 2x, x squared plus 3x plus 2 equals 0, and negative 3 plus x equals 10. Copy that? So, polynomials, definition, monomials, or some are different of monomials. Monomials meaning that it's an expression of one term. So the number 2 is one term, one expression. X squared is one term, one expression. Negative 3x to the 4th is one term, one expression, but then they're adding another monomial. And notice here it says sum or difference on monomials. Yes, this one. About the last one, x squared is a monomial. They subtract 3x, which is another monomial, plus 2, which is another monomial. That's why the definition is monomials or sum or difference of monomials. Another definition that I gave you guys in the past, I broke down the term polynomial. Poly meaning many. Nomial meaning part or term, so many terms. Look at the non-examples. Looking at the non-examples, why are these not polynomials? Why are these not polynomials? Mia, take it.
Because, you know.
Yes,
You know.
yeah. Okay, let me repeat that a little bit different. Look at all the polynomial examples. Look at the non-examples. What
They
is,
have equal signs.
Yeah,
They
they're
have-
equations.
yeah, they are equations. So that means polynomials are what? If they're not equations, they are. Very good. Hashtag expressions only. Yes. And the other one, hashtag various terms. That's fine. I'm going to give you the hashtag since we already have this in our notes. I'm just revisiting. Okay. So let's get started right away with the practice. Ready? Example 1. Copy this. Example 1 reads, divide using synthetic division. And we are given the first polynomial is 3x cubed plus 22x squared plus 37x plus 10 divided by x plus 5. Copy that. And I'm going to go over this one, even though you know how to do it by now. I'm going to go over it step by step, this one more time so that you can have it. Okay, copy that really quick. And here goes one more time. Step 1. Step 1, we need to check the degrees to make sure it's in standard form. So I'm going to start with a dividend. So this one is to the 3rd degree. This one is to the 2nd degree. This one is to the 1st degree because it's an invisible one right there. This one doesn't have a variable, so it's 0 degree. Is it in standard form from highest to lowest? Yes, 3, 2, 1, 0. Are there any missing? Pay attention to that question. You need to have that question in your noodle. Are there any missing? No. Okay, let's go to the next one. 1st degree, 0 degree. Standard form, yes. Anything missing? No. From there, to get started, I take my divisor, which is x plus 5, and set it equal to 0. Solve for x. X equals -5, and that's the number I start with for my synthetic division. That's going to be my divisor. Now that I have that, synthetic division, the point of all this is doing division without any variables, just using coefficients and constants. So for the dividend, we start with a coefficient of 3 for the 3rd degree, 22 for the 2nd degree, 37 for the 1st degree, and 10 for the 0 degree. We always bring down the first term, and then we start our multiplication. -5 times 3, we bring that up right above that, -15, and we combine 22 minus 15, that is 7. Do the multiplication again. -5 times 7, that's -35. Therefore, 37 combined with -35, that's 2. Do the multiplication one more time. -5 times 2, that's -10. Since that's my last term, that's going to be our remainder. Let's see. 10 minus 10 is 0, so that means we have 0 remainder. Therefore, the 3 was the quotient of the 3rd degree. But once we do the division, this 3 now became to the 2nd degree. It loses what? 1 degree. So this is 3x squared. 22 was to the 2nd degree. That means 7 is no longer to the 2nd, it's to the 1st degree. So that's plus 7x. 37 was to the 1st degree. That means the 2 right below it is to the 0 degree, which is our constant. That is plus 2. And this is our quotient. Quotient is the result of a division. Did we just divide? Yes. Okay. And what have I been saying on the warm-ups? If we were to multiply our quotient times the original divisor, we get the dividend that we started with. Okay? All right, I did this one completely. You're going to do this next one by yourself since we've got plenty of practice and I already showed you the process. Here it goes. Example 1 cubed. Copy this. It reads, divide using synthetic division and polynomials given, 10x cubed plus 31x squared plus x minus 6 divided by x plus 3. Copy that and go. So let me go through the process one more time. Then after this one, I'm going to do the rest of them just with one color. I'm using different colors for these because we've already had plenty of practice for these. But here it goes one more time. Standard form, let's see, degree for this one is 3, for this one is 2, for this one is 1, for this one is 0. Are there any degrees missing? No. Is it from highest to lowest degree? Yes, so it's in standard form. For the divisor, 1 degree, 0 degrees in the standard form, yes. Anything missing? No. You take the divisor, x plus 3 equal to 0, minus 3 minus 3. You solve for x, so x equals -3, and that's what we start with, our synthetic division. That's going to be our divisor. From there, we take our dividend, and we only take the coefficients and the constant. So the coefficient of the first term is 10, coefficient of the second term is 31, of the third term is 1, and the constant is -6. We always bring down the first term, and then we start our multiplication. -3 times 10, that's -30. Combine 31 and -30, so that gives us 1. Again, multiply -3 times 1, that's -3. Combine 1 and -3, that's -2. Again, multiply -3 times -2, that's +6. That's our last term. That's going to be our remainder. Let's see what we get. -6 plus 6 is 0, so we don't have any remainder. The 10 corresponded to the third degree, but once we do the division, now the 10 becomes the second degree, so 10x squared. 31 was the second degree, so that means the 1 is the first degree, so that's 1x. The 1 was first degree, so the -2 is a constant, -2. And this is my quotient. Hands if you got that. Okay, good. All right. So from 1 to 5, how comfortable you feel with these? It's on your screen. 1 to 5, 1 being the lowest, 5 being the highest. 5, 5, 5, 5, 4, 5, 4, 5, 4, 5, 5, 5, 5, 5s, 4s. Okay. All right, so I'm going to give you another one. Here we go. We need some more practice. Do this one by yourself. Example 1, supercube. Once again, divide using synthetic division. 12x cubed minus 19x squared minus 12x plus 4 divided by x minus 2. Copy that and go. See if you can do that by yourself. Now that you have the hang of it, see if you can go a little bit faster. All right, let's see how we did. So, I'm gonna go straight to the division. So you should have done all the standard form, yada, 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 and so on and so forth. So you started with our divisor of 2. The quotients are 12, -19, -12, and +4. First term always comes straight down. 2 times 12 is 24. Combined, that's 5. 2 times 5, that's 10. Combined, that's -2. 2 times -2 is -4. That's our last term, so our remainder is 0. That means we have 12x squared plus 5x minus 2. And this is my quotient. All right, hands up, you got that? All right, good. All right, let's move on. Example 1, mega cube. Let's see, yes, copy this one. Same instructions, 7x cubed minus 6x plus 9 divided by x plus 5. 7x cubed minus 6x plus 9 divided by x plus 5. All right, so I'm gonna go over this one together with you guys. We're gonna do this one together. And I'm gonna go through the process one more time to make sure we got the process down. Here it goes. First step, is it in standard form, the first one? Let's see, third degree. This one is first degree, and this one is 0 degree. Is it in standard form? Yes, from highest to lowest, that's standard form. However, are there any degrees missing? Yes, the second degree. So I'm gonna write it here so that I won't forget it, because we need to use that in our division. Let me go to the next one. First degree, 0 degree, standard form, yes. Anything missing? No. So then x plus 5 equal to 0, minus 5 minus 5, x equals to -5. So I start with -5. That's my divisor for my synthetic division. And let's go with the coefficients. With my first coefficient, 7. What would be the next degree after the third degree? Well, second degree. Did we have a term for the second degree? No. So what would we write? 0. 0 for the second degree. Let's go to the first degree. What is the coefficient? -6. And what is the number for our 0 degree? That's +9. All right. Bring down 7. Here we go. -5 times 7. That's -35. Combine, that's -35. Again, -5 times -35, that's 175. Combine, that's 169. Again, -5 times 169 goes up here. That's -845. And that's going to be a remainder, -845 plus 9, that's -836. So, let's see. We end up with 7x squared minus 35x plus 169. Since this one has a negative, I don't need to put a little plus there. I just write -836 over the original divisor, which is x plus 5. And this is my quotient. Yeah? We good? Yeah? All right. I'm going to give you one of these to see how you do with one of these by yourself. This was example 1 mega cube. Let's go to example 1 super duper cube. 6x squared plus 4 divided by x plus 2. 6x squared plus 4 divided by x plus 2. I'll give you some time, copy, and go. Let's see how we did. So first things first, we check for standard form. The first one is to the second degree and to the 0 degree. Standard form, yes, from highest to lowest. Are there any degrees missing? Yes, to the first degree. I'm going to box it to remember it. Okay. The second one, first degree, 0 degree. Standard form, yes. Anything missing? No. X plus 2 equal to 0, minus 2 minus 2. X equals -2. That's going to be my divisor for synthetic division. There it is. I use my quotient. The first one is 6. Next degree up was the first degree. Since there's nothing there, I use 0. 0 degree is 4. I bring down the first term. That's 6. -2 times 6, that's -12. Combine, that's -12. -2 times -12, that's +24. Since that's my last term, I'm going to write remainder. 24 plus 4, that's 28. So this was second degree, now it became first degree. So this is 6x, that means this is my constant, plus 28, the remainder over the divisor, x plus 2. And this is my quotient. Hands, have you got that? Okay, good. How are we doing? Yes? All right. And one last one. Ready? Here we go. Example 1 Shazam cube. Copy this. X cubed plus 5x squared minus 17x minus 21 divided by x minus 3. Copy that and go. All right. Let's see where we at. I'm not going to go over the whole process. I'm just going to go straight to the division portion. So we got 3 as our divisor, and our quotients are 1, 5, -17, -21. Bring down the first term. 3 times 1, that's 3. Combine, that's 8. 3 times 8, that's 24. Combine, that's 7. 3 times 7, that's 21. That's my last term. So my remainder is 0. So we're left with x squared plus 8x plus 7. And that's my quotient. All right. So let's see where we're at. From 1 to 5, how comfortable do you feel with these now? It's on your screen. From 1 to 5. 5, 5, 5, 5. Sounds like those phone numbers from the movies, right? 5, 5, 5. Blah blah blah. Yeah. 4. Okay. 5 4s, 5 4s. Okay. All right, so I think we got this, yes? Yes, Mr. Q. All right, so reminder, here goes again. Let's see. Your home play for tonight is going to be with your synchronous code at P46IQ. P46IQ. You should have turned in your pop party already on Canvas. And your 8 problems that are on the screen once again. But notice that they use different variables. We use X throughout, but I included some that have the variable R, variable N, V, and different variables, but it's the same process, okay? So that's extra practice for you guys. I just want to make sure that you get the extra practice in before next week. And also next week, you guys ready, some of you, for face-to-face? Let's go. I'm going to see some of you on Thursday. Is that correct? Yeah? All right. But other than that, that's going to be it for today. I'm going to see you guys on Tuesday so we can get started with our next concept. All right. Have a good one, guys. Enjoy your weekend. Enjoy your home play. And I'll see you guys next time. Peace. Bye.
Mr. Q, can I see the nearpod code?